So over to you.
Thank you. Welcome, everybody. This presentation, although unknowingly, ties back on many levels with the one that we had here before the lunch break. I'm also going to talk about enterprise stuff, or what's important in an enterprise setting. A few words about me. I'm older than I care to admit, and I've been in the data business for quite long. And we're doing a lot of projects with a lot of tools, so we're agnostic in that regard. And today I'm going to talk about BigQuery. I'm heading the analytics engineering team at Hiflylabs. Hiflylabs is a data consultancy. We do lots of projects. We have been in the business for like 20 years. We are over 150 strong. Operating mostly from Budapest, although we have colleagues around Europe, and now we have the first colleague in South America, so around the world as well. Okay, so access control. It's something that's pretty important once a solution or a framework wants to enter the enterprise world. For most projects at the beginning, you don't really do or have to do much access control at all. And if you do it at what I call it at an object level. So you do it at the project level or data. Well, it's Google has a slightly unconventional terminology around objects that we have in the data world. So projects in Google BigQuery or Google Cloud is something similar to what we used to refer to as databases, and data sets what we usually refer to as schemas, but I will use the Google terminology. So it's obviously possible to allow users or deny users from using a certain database or a certain data set. That's pretty trivial in every setting. You can obviously enable reading and writing, although it's very unconventional for analytics warehouses to allow users to actually update data there directly. So that's something we almost never do. You can enable in Google. You can enable user groups, or all users in an organization, and the word. Those are the levels that you can authorize users. It's not very granular, but in practice it works reasonably well. Okay, that's going to be what the presentation is like. So I'll talk about a little bit what's available in Google, and then I will show you how you can apply those principles in DBT. Fortunately, well, actually, it's not directly DBT. It's DBT's BigQuery connector that provides these services. So out of the box, it's possible to apply object-level access control to models, seeds, and snapshots. You can apply it at different levels. So you can apply it at the project level, a DBT project, and you can apply it on a per model level. What I would like to show you, these are excerpts from actual projects. There's a few things that I want to emphasize. One is this plus over here. That means that it applies to all models. If it were under like MARTs, then it would apply to all MARTs models. This is in this instance, and this instance only, is different from that plus that you can have over here in the grants part, because it's possible for models to overwrite or define additional grants. This definition grants these rights but revokes everything else. So that's pretty much all the users get. And this last one, oh, sorry, this last one adds that one row to the existing ones. This is something that I'm pretty sure nowhere else in the DBT world exists, that plus. The other one is fairly standard. Okay, so that's object level. That's not very interesting, usually. Where it gets interesting is something that Google has and nobody else, as far as I know, has in this way. The core idea is to allow users to read from certain views without allowing them to access the source of those views. This is very unconventional. So if you allow a user, if you deny a user from a source of a view in most data warehouses or most database systems, they will not be able to select from the view either. Now, this is something that's possible in BigQuery. Why would that make sense at all? I brought, I guess, 2 use cases, but no, I only brought one, but I can list a few. One is where you want the users to access the MART layer, but you do not want them to even see the other tables, like the intermediate and stage ones. What we normally do is that we deploy it into a different data set. That's fair enough. Then they wouldn't see the other ones. Except if you, for any reason, have to have views in the MART layer that refer back to the intermediate and stage layers. If you happen to have one of these cases, I can tell you examples later where it's useful. Then you have to authorize the other views, data sets as well. And then they will see whatever is in there, and they will start using it, believe me. So if you want to hide implementation details, then you can make queries able to read from one data set and not allow direct usage. That's what's in the graph. So suppose that the raw data is here. You have a view over here that the users can access. They cannot read the raw data. They can only access the data through these views. This is something it's called authorized views. You can authorize data sets and authorize routines as well. Actually, data set authorization is more widespread in my practice than an individual view. That means that for a data set, for a given data set, for example, for analytics staging, you can authorize a view or another data set to access it, but not the users who can access the other data set. It also has DBT support, although it's in my experience, it's a little bit backwards. What it does is that you can define a model that reads from another data set, and for the other data set, DBT will try to set up the rights. That means that DBT user, the technical user or service user that DBT runs has to have a lot of rights over the other data set, which is something we don't usually allow. So we usually do it outside of the project, although it's built into DBT, but we very rarely use this. It also has a lot of caveats, but it actually exists in DBT. So the core idea is that you can allow users to read from a view, but not read from the view's sources. It's very useful, for example, not only hiding implementation details, but for example, in certain data security situations, for example, users can read aggregate salary data, but they are not allowed to read individual salary items. You can define a view in the data set that they access that aggregates the individual records, and they can read that, but they will not be able to read the individual records. That's very useful. Cool. Now the third level we often have to use is record level access control. Record level access control is, or sometimes it's called row level access control. It's something when we authorize users to read, to be able to access certain rows in the table, not necessarily all, but certain ones they can. And for other rows, they don't see them at all. So they don't even, they are not even aware of those rows. That means that when a user calculates an aggregate, they will only aggregate the data on the rows that they see. So for example, for the East region, if these are, let's say, revenues or something, for some month, sorry, should have. So for some months, these are revenues for each region. And if somebody is only allowed to read the East one, they can whatever these add up to, they will only see the 300 that they add up to. Another user is allowed to use the West region, so they will only see the West ones. And for example, the CEO can see everything, and then they will have a different figure. This sounds like a very good idea, especially for business users. They really like it. So they can hide data from one another. It usually takes me quite a while to try to explain for them why it's not a very good idea, but they want to do it anyway, so we do it. And along the lines, sometime later, they figure out that it was not a good idea in the first place, so they authorize everything to everybody because they can't work. Why it's not a good idea? Problem one, which is listed 3 there, but that's the core of the problem, is that everybody sees a different figure. And if you, some of you may remember why we started to create data warehouses in the first place, because CEO was fed up that everybody brought in different figures for what should be the same figure. So people see different figures, now they have different figures, now they don't reconcile again. So that's something. Another problem is that in certain cases, and it's unfortunately too many cases, figures that you don't see can be inferred, at least to an extent. So for example, in this case, if I only see my, maybe I'm the East manager, and I only see my figures, and the CEO announces what the quarterly revenues were, I can easily calculate the other figures, not on a monthly basis, but on an aggregate basis. And it doesn't look like a great problem, but it is. But for example, if I can't see any individual salary, but I can see the department's monthly salaries, and for whatever controlling reason. And I know that only one person joined the company in that month, I can pretty much infer what the person's salary is. So it's, you have to be very, very careful around this. And the third one is, in many cases, for whatever reason, people try to do it on their own. I mean, I will insert the appropriate where clause in the wherever it needs to be inserted. Sooner or later, it's going to be messed up. So don't try to do it on your own. So if you have to do it with your tools built-in features. BigQuery has this feature, so you can set up row access policies on the tables. They are actually combinable, so you can you can set up more, and then they can be combined. That's exactly how you can do this east-west CEO stuff. So the CEO's group or user will be allowed to read everything, whereas the others only their own. Okay. What it does in the background is inserts something like a where filter or a where-like clause into each query. Though it also has a few caveats. You can only do it on tables, so you cannot do it on views. That's sometimes a problem. That also means that you can only do it on the fields that are in the table. So whatever you filter on cannot be something that you join in from somewhere else. It's sometimes a problem, sometimes not. For example, if only a list of users are allowed to read a row, sometimes you have to have their emails or names in the row so that everybody will see that. That's not very convenient at times. And there are a few other technical caveats that I don't want to really go into, but they may be important in certain situations. And also, it has happened to me, that's why I list here. Make sure that your technical accounts, for example, the DBT account, sees all rows. If you don't define, if you define row access policies and you do not explicitly allow a user to be able to read all rows, they won't see anything. So it has happened to me that I didn't understand why DBT behaved the way it did, and that was because the service user had no rights on the rows. Okay, this is unfortunately, I would say, unsupported in DBT. That was the old way, if anybody remembers, how we could define grants in DBT. That's the standard post-hook method. So you actually have to create these row access policies. That has quite a few problems. One of the problems is that it's very difficult to know what policies are defined at the point when you start defining new ones. So you either redefine everything, drop everything and redefine everything, or has to be very careful. Okay. This is, well, the row access policy is pretty simple. It's the one thing that I wanted to show you. I'm not sure if you're aware of this. It's fairly widely used, but maybe not non-trivial. You can use this here. So in a post hook, DBT will happily insert the name of the model for this variable. It's only usable in the config block. That's useful. Okay, and now comes probably the last one, and that's when you don't. It's not rows that you want to hide from users, but columns in a way. So, for example, if there are PII information in in one of the columns, you may want to hide that from users, or maybe there are lots of KPIs in a table. Let's say all of your KPIs, but certain users are not allowed to access KPIs that have that depend on salaries or have some sort of protected information. There are a few ways to go about this. One is what we used to do earlier is that we created a copy or a semi-copy of the table without those columns. That's okay for as long as there are not very many different groups, but if you have like 2, 3, 4 different groups that have different access rights, it becomes just unwieldy. The other possibility is that you actually hide those columns as if they didn't exist. And the third solution is that you hide you keep the columns, but you hide the values. All three are available in BigQuery, but they're not. It's not non-trivial which one to apply. If you hide columns, that's fair enough, but then you often break user tools. For example, dashboarding tools usually suppose that columns are there, but whichever user looks at the table. They usually don't play very nicely with columns that don't exist. So it's easy to break user tools in that regard. If for one user the column is there, for another it's not there. If you mask the values, it's a very intricate question how to mask it, especially in BigQuery. Snowflake is more flexible in that regard, but BigQuery has a certain set of masking policies built in, and sometimes it's not, neither one or none of them is really applicable. For example, for numerical figures like for salaries, you can basically only use to null those, which is either good or not, depending on what the use case is. And it takes a lot of focus to set it up and to set it up correctly. Again, these information are going to be present in many tables across the application. So you have to be very careful to mask it everywhere. Okay. It's really difficult to set it up in BigQuery. It's technically possible, but it's really difficult. It takes a lot of steps. Sorry. You have to set up a taxonomy of policy tags and basically assign these policies to columns. And if you want to mask it, you even have to define what masking policy you want to use, and so on. This ties very heavily into the data governance tools built into BigQuery, whereas the other access control methods you can use independently of this metadata management thing. This is also a somewhat supported part in DBT. You can set policy tags for columns that's built in, although you still have to define the policy tags out of bounds. I mean, out of the project. And yeah, these are perhaps the. So this is half-hearted. I mean, it's not very useful, honestly, to have these into have to define these into the projects, whereas on the columns, whereas their definition is outside. It's in certain situations it may be useful, but I would suggest that you only go this far if you absolutely have to. In general, what I would suggest is that you go as simple as you can. If it's enough for you to mask, control access on objects, that's the easiest one, the easiest to follow and the easiest to understand. And as you go deeper and deeper into the details, and even combine these with one another, row policies with column policies, which is possible, it's going to create a really hard to manage situation. That's what I pretty much wanted to say. If you have any questions, I'm happy to take them.
No question. Is there any question in the room from the audience? I have a question myself. Sure. I just go forward. You mentioned on the slide that sometimes you recommend using DBT to set up the permissions, other times you don't. How would you make a decision?
What we normally do is that on object level, we do the grants in DBT. If even row level policies are usually in DBT. What we don't do in DBT are two things. We don't do in DBT column level policies. Actually, I have successfully defended not to implement any of this on any client project so far. So I'm happy in that. And the other thing that we don't do within DBT is cross dataset authorizations that we usually do out of bounds, because there are only so many datasets that we use. A few, I mean, less than 10 on a project usually, even accounting for raw datasets. So that's something we do out of bounds. Other than that, object level we do in DBT, and yeah.
Thank you. Any other question?
There's one thing I promised that I will talk about, and I have 2 more minutes, so I'll just do that. Is one situation where it makes sense to have views in the Mart layer. That's quite unusual. Usually we only have tables in the Mart layer, or if we have views, they are pointing within the Mart layer and not below that. But on several projects we have found that users want to have certain configuration control or want to have manual input in a way. So for example, through Google Sheets, which integrate very nicely with BigQuery, they want to have Google Sheets that they can tweak, and whatever they do there would show up in the warehouse very promptly. And the way it's implemented is that we have a set of views that point back to the Google Sheets right from the Mart layer, which means that the Mart layer has to reference at least sometimes the intermediate, but the stage layer anyway, and then the raw layer. So that it gets updated like in real time. So that's one of the cases when you have views in the Mart that point back to the stage layer.
That's very good. That's perfect. Actually, as I was about to ask a very similar question, yes, thinking about the governance side. When you are approaching this security from the governance side, obviously, most of the times, whoever make decisions about which object, columns or rows can be seen is not probably the same guy who is doing the DBT implementation. So how would you handle, what would you recommendation, how to handle it with DBT when you have data governance and someone created a rule and you have to implement this solution in DBT?
What we usually, unfortunately, we have not had so huge enterprise implementations, so I can't really speak from experience in that regard, but I would go with, like with many things, I would go with definitions. I mean, formal definitions from somebody and authorizations by whoever can make those decisions. There's a very interesting aspect of this is whatever is available for the developers to develop on versus whatever is available for the production system to run on, because they may not be the same things. So production systems may use data sets that are more thorough or more real than the ones that developers can develop on. There are ways to go around this, but that's also an interesting question. Who can see what in that regard?
Yeah, very nice. Thank you so much. We are going to continue with the next session at 10 past 14. So until then, we have a couple of minutes.